In the previous videos of time value of money, we have looked at the concept of future value of an annuity. In this video, we will look at the concept of present value of an annuity. Now let's recall what is an annuity. So an annuity is a series of equal payments made at fixed intervals for a specified number of periods. So in order to understand the concept of present value of an annuity, let's first take the case of an ordinary annuity. Now again, what is an ordinary annuity? So if the payments occur at the end of each period, the annuity is called an ordinary annuity. Now suppose that you won a lottery and the lottery offers payment of prize money in two options. The first option is that they will pay a 3-year payment of rupees 1000 at the end of every year. The second option is a lump sum payment today. So let us look at these options on the time scale. So let's say this is 0, 1, 2, 3. So in the first option, they'll pay 1000 rupees at the end of each of the 3 years. So I've kept this positive because it is incoming payment. So you are receiving these payments. So this is coming into your pocket. So this is the first option. The second option is that right here you get a payment of X rupees. Now you are trying to find the lump sum amount that you will get as part of option number 2. You go to a bank and inquire about the interest rate that they can offer, and they say that each year they can offer a 5% interest rate which is compounded annually. So basically, if you put this X rupees in the bank today, you will get 5% interest compounded annually for the next 3 years. Now in case of future value of an annuity, we were trying to find the value of this annuity at the end of the 3-year period, or we would have found the amount that this X rupees get converted at 5% interest rate compounded annually at the end of 3 years. However, here we are trying to find out the present value, that is, what is the value here of this 3-year annuity of 1000 rupees invested at the end of every year. Now, in other words, the present value of an annuity is the single lump sum payment today that would be equivalent to the annuity payments spread over the annuity period. In slightly different words, it is the amount today that would permit withdrawals of an equal amount at the end in case of ordinary annuity, or beginning in case of annuity due of each period for n periods. So basically what that means is, what is this X amount such that at 5% interest rate, if you put this money, that is the X rupees, then you can withdraw 1000 rupees at the end of first year. The remaining amount continues. So the remaining amount that you have invested at the beginning continues to gain 5% interest. Again, you can withdraw 1000 rupees at the end of second year. The remaining amount still continues to gain interest for the third year, and then again you can withdraw 1000 rupees at the end of 3 years. So in order to find out the X rupees, which is equivalent to the annuity payments spread over the annuity period, we will use the concept of discounting. Which is nothing but the reverse of compounding. So basically what we are going to find is what is the value of PV1 which at 5% will get converted into 1000 rupees at the end of 1 year. So what is the current value of this 1000 rupees in 1 year period at 5% interest? Next we have to find what is the present value, so PV2, of this 1000 rupees that we get after 2 years. In other words, what is this value which in 2 years time frame at 5% interest rate per annum compounded annually will get converted into this 1000 rupees. And same thing for these 1000 rupees. What is the current sum of amount which at 5% interest compounded annually for a 3-year period will get converted into 1000 rupees. And this total, that is PV1, PV2, PV3, will be equal to this X rupees. So in other words, if we deposit this amount PV, then we can withdraw 1000 rupees at the end of first year, 1000 rupees at the end of second year, and 1000 rupees at the end of third year, if the interest rate is 5% per annum compounded annually. Now let's calculate these PV1, PV2 and PV3 independently. So this is a case of compound interest. So the formula for compound interest is the final amount at the end of n periods is equal to the original amount or the principal value into 1 plus r, which is the rate of interest per compounding period, divided by 100 to the power n, where n is the number of compounding periods. So let's take the case of PV1. So PV1 is the present value, which is nothing but P, and A in this case will be 1000, because this is the final amount that we are getting after 1 year. Okay. So A is equal to PV1 into 1 plus R, which is 5%, divided by 100 to the power n, which is in case of PV1 1. So this is equal to PV1 into 1 plus 0.05, which is equal to PV1 into 1.05. So therefore A is equal to PV1 into 1.05, or PV1 is equal to, now A is 1000 divided by 1.05, So this is equal to 952.38 rupees. So let me note this down here. PV1 is equal to 952.38 rupees. Or actually I can note it down here. So 952.38. Now let's proceed to PV2. So again, A is equal to PV2 into 1 plus R by 100 to the power n. So A is 1000, PV2 is to be found out, into 1 plus R, R is 5% per year, divided by 100. N in this case is 2 years because we are getting this 1000 rupees at the end of second year. So this is equal to PV2 into 1 plus 0.05 to the power 2. So this is equal to PV2 into 1.05 to the power 2. So now this is 1000 is equal to this. So PV2 is equal to 1000 divided by 1.05 square. So this is equal to 907.03 rupees. So this is equal to 907.03. Let's move to the third one. Now we'll simplify this formula. So A is equal to P into 1 plus R by 100. Let's consider this R by 100 as I. So A is equal to P into 1 plus I to the power n. And since we are trying to find P here, so P is equal to A divided by 1 plus I to the power n. So let's use this for ease of calculation. So let's now move to PV3. So PV3 is equal to A, which is again 1000, divided by 1 plus I. I in this case is 5 divided by 100, which is 0.05. So 1 plus 0.05, and n in this case is 3. So this is 1000 divided by 1.05 cube, and this is equal to 863.84 rupees. So this is 863.84. So let's find out the total. So the total is 2723.25 rupees. So this is the value of X, which if invested at 5%, then we can withdraw 1000 rupees at the end of first year, 1000 rupees at the end of second year, and 1000 rupees at the end of third year. Also, if you note, the present value is decreasing as the tenure is more. So we need less money if we invest for 3 years to get 1000 rupees at the end of 3 years, as compared to getting 1000 rupees at the end of second year, and again as compared to 1000 rupees at the end of first year. So here we calculate PV1, PV2, PV3 using these formula for compound interest, but this can become very tedious if you have a large number of years for which you have invested the money. So let's try to derive a formula based on these calculations that we just performed. Now, how did we calculate the present value in the example that we just saw? So we had PV, this is the total present value. So this was equal to the present value 1 plus present value 2 plus present value 3. And what was present value 1? That was A. which was the amount 1000, divide by 1 plus I to the power 1. This was the first year. So we had 1 year as n plus a divided by 1 plus I square plus a divided by 1 plus I cube. So this was for the second year and this was for the third year. And this total was present value for 3 years. Now if we try to generalize this formula, we get present value for n years. N years in the sense this is an annuity of n years will be equal to a divided by 1 plus I to the power 1, because we'll have any investment which is going to give us an amount at the end of first year. So this thing will look like this. So you have 0, 1, 2, 3, 4 and so on up to n minus 1 and then n. So you'll have 1, 2 and so on. So this is a divided by 1 plus I to the power 1, which is whatever you are getting at the end of first year, plus a divided by 1 plus I to the power 2 and so on. And at the end you'll have a divided by 1 plus I to the power n minus 1 plus a divided by 1 plus I to the power n. So let's say this is our equation number 1. Now let's multiply both the sides, that is left hand side and right hand side, by 1 divided by 1 plus 1. Now let's multiply both the sides, that is the left hand side and the right hand side, by 1 divided by 1 plus I. So multiply both sides by 1 divided by 1 plus I. So here we will get PVN, and we are multiplying by 1 divided by 1 plus I. So this will become 1 plus I is equal to 1 divided by 1 plus I into bracket a divided by 1 plus I to the power 1 plus a divided by 1 plus I square so on plus a divided by 1 plus I to the power n. So or PVN divided by 1 plus I is equal to, now let's take this 1 plus I inside the bracket. So it becomes a into 1 plus I to the power 1 into 1 plus I, and again this can also be written as 1 plus I to the power 1 plus a into 1 plus I square into 1 plus I to the power 1 plus a divided by 1 plus I to the power n into 1 plus I to the power 1. Now we know that x to the power n into x to the power 1 is equal to x to the power n plus 1. So this base is the same. So if we are multiplying these two, then these exponents can be added. So similarly here 1 plus I is the same. So let's see what we get. So or PVN divided by 1 plus I is equal to, so the first term becomes a divided by 1 plus I to the power 1 plus 1, which is 2, plus a divided by 1 plus I to the power 2 plus 1, which is 3, so on plus a divided by 1 plus I to the power n plus 1. Let's call this equation 2. Now let's subtract 2 from 1. So basically we'll do 1, which is this, minus 2, which is this one. So this will get negative signs, minus, 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 and minus. Now a divided by 1 plus I to the power 1, that is not present in equation number 2. However, a divided by 1 plus I to the power 2 and the terms after that will be present in equation number 2. So each of these will cancel each other. This will also get cancelled here. Similarly, a divided by 1 plus I to the power n minus 1 will get cancelled with the similar term here. And then we'll also have a divided by 1 plus I to the power n, which will be before this last term here. So that will get cancelled with this term here. So now what we get is a divided by 1 plus I to the power 1 minus a divided by 1 plus I to the power n plus 1. So let's write the resulting equation. So on the left hand side we'll have PVN minus PVN divided by 1 plus I. So PVN minus PVN divided by 1 plus I is equal to a divided by 1 plus I to the power 1, a divided by 1 plus I to the power 1 minus a divided by 1 plus I to the power n plus 1. Now let's multiply both sides by 1 plus I. So we'll get 1 plus I into PVN minus PVN divided by 1 plus I equals to a divided by 1 plus I minus a divided by 1 plus I to the power n plus 1 into 1 plus I. So let's open the brackets. So or 1 plus I into PVN minus 1 plus I into PVN divided by 1 plus I is equal to a into 1 plus I divided by 1 plus I minus a into 1 plus I divided by 1 plus I to the power n plus 1. So this 1 plus I in the numerator and denominator gets cancelled. This also gets cancelled. Now the denominator here can be written as 1 plus I to the power n into 1 plus I to the power 1. And the numerator is 1 plus I to the power 1. So the numerator and this portion in the denominator will get cancelled. So what we get is a divided by 1 plus I to the power n. Or now let's open this bracket also. So 1 into PVN is PVN plus I into PVN minus PVN is equal to a minus a divided by 1 plus I to the power n. So this PVN gets cancelled, or PVN is equal to, now we'll bring this I on the other side, and at the same time we'll take a as common. So a into bracket 1 minus 1 divided by 1 plus I to the power n divided by I. This I is this I here. I mean, this can also be used as the formula. However, this is little complex to remember. So let's simplify it further. So let's take 1 plus I to the power n as LCM. So what we get is, or PVN is equal to A into LCM is 1 plus I to the power n. So here we get 1 plus I to the power n minus 1, and this is all divided by I, so I can be brought here. Now this can also be written as A into 1 plus I to the power n divided by I into 1 plus I to the power n minus 1 divided by I into 1 plus I to the power n. So this gets cancelled. So we get, or PVN is equal to A into 1 divided by I minus 1 divided by I into 1 plus I to the power n. So this is the formula for calculating the present value of an annuity in cases of an ordinary annuity. Now let's use this formula to calculate the present value that we calculated earlier. So this was the information given to us. The annuity amount is 1000 rupees for 3 years. Interest rate is 5%, so I is 0.05, and the type was ordinary annuity because the payments were at the end of each period, and we had to find the present value. So the formula for present value for an ordinary annuity is A into 1 divided by I minus 1 divided by I into 1 plus I to the power n. So let's plug in the values. 1000, 1 divided by 0.05 minus 1 divided by 0.05 into 1 plus 0.05 to the power n, which is 3. So let me pull my calculator here. Now let's first calculate this part, and specifically this part. So 1 plus 0.05, this becomes 1.05. So 1.05 to the power 3, so cube, multiplied by 0.05, so multiplied by 0.05. Now this is in the denominator, so we'll do the reciprocal, that is 1 by this value. Now this is a negative sign, so minus, and then we'll add 1 divided by 0.05, so 0.05 1 by x, and then this value multiplied by 1000. So the present value we get is 2723.24 rupees, or 25 rupees. Now the value that we had gotten earlier by calculating the present value for the 3 years was also the same, which was 2723.24 rupees. So instead of doing the tedious calculations, we can use this formula to find the present value of an ordinary annuity. Next, we'll look at how to find the present value of an annuity due.